Hello, welcome to Algebra 2. We're going to go ahead and do lesson 83. I don't know why I put that there. Well, it's writing quadratic equations by its roots. I think this is a very fun lesson. Again, you guys, if you don't like math, this is not as fun. But looking over here, we have two binomials. Lately, we've been focusing on problems. We set them equal to 0, and we solve for what x could be. And then we have our roots. You know, the real numbers, they're just whole numbers. Here we have x minus 3 times x plus 5. If we set it equal to 0, we can find what x is. We have here x minus 3 equals 0, so that means x is equal to 3. X plus 5 equal to 0, and that means x is negative 5, and these two are your roots. What we're actually doing is we're working our way backwards. So we have our numbers here, and we're working our way backwards to have an actual quadratic equation. To do that, here, example 1, we have two roots. They gave it to us as 3 roots. What I like to think of it as is when you're displaying it as binomials, you're going to think of opposite signs. For negative 3, I have x plus 3 equals 0. And then here for 5, I have x minus 5 equals 0. I think of opposite signs. Set them not equal to x, but set them with x with opposite signs. Because if I were to solve for this right away, I would subtract 3 to both sides, and I'll have x is equal to negative 3, and that's why it'll match up. Same thing here. If I add 5 to both sides, my roots will not be 5. So here we're doing the opposite of that. Now we're trying to get into a quadratic equation. Now, you have your two binomials. Then, I have it here, remember, opposite signs. You have x plus 3 times x minus 5. From this point here, we're going to go ahead and multiply it because we want a quadratic equation, means x squared plus, that plus that. We're going to do FOIL, so x squared minus 5x plus 3x minus 15. So x times x times negative 5, 3 times x, 3 times negative 5, and you end up with this. You want to simplify even more, x squared minus 2x minus 15. And that's what you're doing. So you're working your way backwards from the root. B, here says you have two roots here, but they want you to write 3 different equations from it. Because this equation here doesn't mean that this is the only equation that has a roots of negative 3 and 5. There are multiple equations that you can create, and it's actually very simple. First, we're going to find the original one. So, okay, negative 4 and negative 1. So we're going to do opposite signs, x plus 4 and x plus 1. So opposite signs, set them with x. You can have them as equal to 0, but here I was just showing you why it came out as negative 3 and 5. So here, I set them with x with opposite signs. I go ahead and multiply it out. So x times x is x squared. X times 1 is x. 4 times x is 4x. 4 times 1 is 4. Go ahead and simplify that even more. I have x squared plus 5x plus 4. This is one equation. We want 2 more equations. Again, there's not a correct answer for this because there's so many different opportunities. Sorry, it's my leg. There are so many different opportunities for you to create equations. Here, let's say from this original equation, let's go ahead and multiply it by 2. 2 times the x squared plus 5x plus 4. If we were to multiply the 2 in place of this, so distributive property, I get 2x squared plus 10x plus 8. And that is my second equation. Let's say I want a third one, so let's do a number that's negative. Let's do negative 1. So negative 1 or negative times x squared plus 5x plus 4. Let's go ahead and multiply it out. You have negative x squared minus 5x minus 4. And that is the third equation. You can use any number you want. You can use a fraction, and they will all end up with the same roots as negative 4 and negative 1. Example 2. This is when we deal with completing the square. We only have one possible root. Here we have a root of 6. Again, when you're doing trinomials, you still need 2 binomials. So we're going to have here is x minus 6. But since we only have one root, that typically means you have 2 of the same one. So now here, we have x minus 6 times x minus 6. You set it with the opposite sign of that number there. And then you go ahead and multiply it out. So you have x squared minus 6x minus 6x plus 36. Then I have x squared minus 12x plus 36, and that is my equation. So if it's one root, that means it's the same root used twice. Here, we have a root of -2, and we have to write 3 separate equations from this. So the first thing we're going to do, find the original trinomial. So we're going to set this with the opposite sign, so x plus 2. If it's one root, that means it's 2 of the same kind. X plus 2 times x plus 2. Multiply it out. X squared plus 2x plus 2x plus 4, which gives you x squared plus 4x plus 4. If you want to make sure and see if you got the right answer, just factor this out. If you end up with this, that means you're doing it right. Or if you end up with roots of -2, like both of them are -2, that means you also did it right. So that's my first one. My next equation, let's go ahead and multiply it by 3. So 3 times that original equation. So 3 times this whole thing, I get 3x squared plus 12x plus 12. And then I end up with that. And now, 3 times 4 is that? Yeah. That's the second one. Let's do a third one. Let's see what I did. I did 2 again, so that's fine. Squared plus 4x plus 4. I end up with 2x squared plus 8x plus 8. And you end up with the same equation there. And therefore, that is, let me see if that's right. Yep. And you have 1, 2, and 3 different types. For your homework, I'm only asking for 2 because I don't think we have that much space to even do 3. So I'm just sticking with 2. 2 of any kind, make sure it actually makes sense. Example 3 is when we're dealing with complex roots. So for complex roots, it's slightly different. Here, we have 3 plus 2i and 3 minus 2i. The first thing you do, you set it equal to x. So it's slightly different. So x is equal to 3 plus or minus 2i. Remember, the signs are different between. We separate them by having 3 plus that, 3 minus that. We're just trying to combine it now. Here, we're going to try to get the I by itself on one side, isolating the I. So x minus 3 is equal to plus or minus 2i. Here, we're going to find the squared version of 2. So when we think of I, before we even focus on 2, we think of the square root of -1. But remember, this is in terms of square root. So what has a perfect square that equals 2? And that would be 4. So I'm going to go ahead and have that here, plus or minus the square root of 4 negative 4i. So we have the -1 from the I there, and we had to, because we're undoing it, we have to find what number gives you 2 as an answer. What has a perfect square? When you simplify, it gives you a 2, and that is 4. So 4 times -1 gives you a square root of -4. From this case here, we're going to go ahead and multiply both sides, or not multiply, but we're going to square root both sides so we can get rid of the square root and get rid of the signs here. This cancels out the plus or minus. So we're left with -4 on one side. Here, x minus 3 squared, we have x minus 3 times x minus 3, and we multiply it out. This will give you x squared minus 6x plus 9 minus 6x plus 9 is equal to -4. Last thing, move the 4 over. And now you have x squared minus 6x plus 13 is equal to 0. So the step that's kind of confusing, it can get confusing, is just looking for that number. So I think of just 2 squared and then have it under the radical. Next one, 3i and -3i. So first thing, set it equal to the plus or minus 3i. So we don't have a number in front, so it's just plus or minus 3i, right? Positive 3i, -3i. Next thing you do, we have an I here, square root of -1. We think of 3 squared and put it underneath the radical. So we have x is equal to plus or minus the square root of -9. So square root of 3 squared is 9 times 1. You're going to have a radical -9 here. Now, you square root both sides. This will cancel all of this out and the square. You get x squared minus 9. Again, you need everything on one side. So if you want everything on one side, you're going to add 9 to both sides. You're going to get x squared plus 9 is equal to 0. If you want to double check your work, just go ahead and factor this if you can. In this case, you can't really factor it. It looks like a difference of 2 squares, but it's not because there's a plus sign there. Difference means you're subtracting. All right, if you guys have any more questions on how to do these type of problems, make sure you email me down there. We have a test on Thursday instead of Friday next week because you have a day off. So enjoy that while you can. If you need to know what you're missing, if you need any extra help, you want to catch up, you're just still trying to get used to it, let me know, or else your grade will be affected by this. You don't want to repeat my class next year. I don't want you to repeat my class next year. So try your best. Bye, guys.